So our example here, we're going to start with the integral from minus infinity to infinity of 2 divided by x squared plus 4. So what we're going to do is we're going to look at the integral from 0 to infinity of 2 over x squared plus 4. And we know how to interpret this. This is the limit as b goes to infinity of the integral from 0 to b of 2 over x squared plus 4 dx. This is an inverse tangent formula. So this is going to be 2 times 1/2 inverse tangent x over 2. And we're going from x equals 0 to x equals b. And so this is the limit as b goes to infinity of. The 2 1/2 cancel out. We get the inverse tangent of b over 2 minus the inverse tangent of 0. The inverse tangent of 0 is 0. And we have to maybe think back to trigonometry. The limit as b goes to infinity of the inverse tangent of b over 2. So remember the inverse tangent, you can think of that graph as the tangent graph on its side. The regular tangent graph has vertical asymptotes at plus or minus pi over 2. The inverse tangent graph has horizontal asymptotes. And so as b goes to infinity, the inverse tangent is going to go to pi over 2. Whoops. So we would say that this integral converges, we get a finite number, to pi over 2. So that's the first half. Now we're going to check with the second half. So now we have to check to see if the integral on the left converges. So we need to look at the integral from minus infinity to 0 of 2 over x squared plus 4 dx. And so what would that limit look like? Well, in this case, b is heading off to negative infinity. Now the good news is I can reuse all of this work. I know what the thing integrates out to. It's the same integral, we just have different limits. So this would be the limit as b goes to minus infinity of the inverse tangent of b over 2, of x over 2, evaluated from, in this case, x equals b to x equals 0. That's the limit as b goes to minus infinity of inverse tangent of 0 minus inverse tangent of b over 2. And once again, the inverse tangent of 0 is 0. And so I'm looking at the limit as b goes to minus infinity of negative inverse tangent b over 2. So once again, looking back at the graph of the inverse tangent, once again, it's just the graph of tangent on its side. We've got these horizontal asymptotes. As b goes off to negative infinity, you can see that the inverse tangent is going to get close to negative pi over 2. So this is going to be negative pi over 2, which is pi over 2. So we've shown that the integral from minus infinity to 0 of 2 over x squared plus 4 dx converges. I get a finite number, 2 pi over 2 as well. So now that I know that both of those parts converge, I can break this up. So this is how we define this thing to work. This is pi over 2 plus pi over 2, which is pi. So this integral will converge to the value pi. So if you have infinite limits on both ends, you chop it up into two parts. You look at the part from 0 to infinity and the part from negative infinity to 0. If both of those parts converge, then the whole thing converges. Hopefully that makes sense. Now this next example here, once again, we've got limits on both ends at infinity. So what we're going to try to do is break this thing up and look at the integral from 0 to infinity, x e to the minus x dx. And the integral from minus infinity to 0 of x e to the minus x dx. So this would be the limit as b goes to infinity of the integral from 0 to b, x e to the minus x dx. And this would be the limit as b goes to minus infinity of the integral from b to 0, x e to the minus x dx. So in both of these cases, I'm going to have to determine the integral of x e to the minus x. And once again, that's a good review of parts. And once again, I've got an algebraic times an exponential. I can use tabular here. I have a column for my u's. U equals x, x, 1, and 0. My dv's would be e to the minus x dx. So e to the minus x minus e to the minus x, e to the minus x. So I've got plus 1 and minus 1 here. So I've got a minus x e to the minus x minus e to the minus x plus c. So that's my antiderivative. Now I'll plug it into my limits. So if I'm looking at the first limit here, the integral from 0 to infinity, x e to the minus x dx. The limit as b goes to infinity, 0 to b, x e to the minus x dx. That's the limit as b goes to infinity of minus x e to the minus x minus e to the minus x from x equals 0 to x equals b. Limit as b goes to infinity of minus b e to the minus b minus e to the minus b minus, plugging in x equals 0 is going to kill off that first term. And I got a minus e to the 0, which is a minus 1. Going through the limit as b goes to infinity, I would have a minus infinity times a 0 here, minus a 0. The exponential wins. So that's going to go to 0. And so we get positive 1 from that limit. So the first part converges. In fact, it converges to positive 1. So are there any questions over that first part? So now let's move on to the second part and see what happens there. If I'm looking at the integral from minus infinity to 0 of xe to the minus x dx, that's the limit as x goes to, not x, but b goes to minus infinity of the integral from b to 0, xe to the minus x dx. And once again, I've already got the antiderivative. The only thing that's different now is I'm flip-flopping the limits. Instead of going from 0 to b, I'm coming from b to 0. So let's see what happens here. When I plug in 0, I get a 0 minus a 1, so I get a negative 1, minus, now I'm going to plug in the b. Oops, and b is going to negative infinity here. So I get the limit as b goes to negative infinity of negative 1 plus b e to the minus b plus e to the minus b. So what's happening here? B is heading off to minus infinity. So I got a minus 1. So I've got a minus infinity times what? E to the positive infinity plus e to the infinity. So what I'm getting is that the negative 1 isn't going to matter here because I'm getting an indeterminate form minus infinity plus infinity. So what I could do is I can factor out here, rewrite this as negative 1 plus e to the minus b times a b plus 1. And this will kind of help us out. So I have a negative 1 plus infinity times negative infinity. So this is negative 1 minus infinity. This actually goes to negative infinity. So this piece actually diverges. In fact, it goes to negative infinity. And we're going to look at the graph of this here in a minute, and we'll be able to see why all this happens. So our conclusion then is the integral from negative infinity to infinity of xe to the minus x dx diverges since the integral from minus infinity to 0 of xe to the minus x dx diverges. Okay? So for that double limit of infinity to converge, you need both of them to converge. If one of them messes up, it throws the whole thing off. Okay? The whole thing messes up.